The first thing you will be asked is a SAS Viya environment where you have access. This is the environment that I'm working with in this demonstration, therefore I'm going to paste it here. Next, you're going to be asked for an authorization method. Choose the default one, which is using an authorization code. A link is generated, and with that link you need to copy it to authenticate using your SAS Viya credentials and paste back the authorization code. Here I'm copying the link from the Python program. I'm going to log in using my credentials. Allow access or authorize access to SAS Pi. So SAS Pi is the client which facilitates the connection from Python to a SAS Viya environment. And the authorization code is generated by SAS Viya. You will need to copy this code and paste it back in your Python program. In a few moments you will get the confirmation that the SAS compute session has been established. By default, for our demonstration, a table is selected and a library. This library and table exists in any SAS Viya environment. You can see here metadata, column metadata, which is captured from the table. That's extremely important because it will be injected into the GPT's system message. So it's a form of prompt engineering to ensure that the generated SAS code is more accurate. When you type help, you will get some sample questions that you can ask about the dataset that you are analyzing. As you can see, the question from natural language is translated using a function called execute SAS code into SAS code. Then the generated SAS code is executed in the SAS Viya environment you connected to. You get the results, the execution results from SAS Viya, and afterwards a summary which is created by the large language model. Let's try another question just for demonstration purposes. One of the good things about this approach is that you can see transparently when the function is invoked by the Azure OpenAI assistant. The SAS code may be generated once, twice, or many times, depending on the complexity of the question that you have asked. When all the statements are executed and the agent, the assistant, receives back the execution results, then you get a response and a summary. As you can see in this example, you have absolute amounts, then an average capital gain and an average capital loss. Let's choose a third question, and let's say that I want to go a bit off script at this point. I will slightly adapt it. As you can see, in the function, the choice for generating code in SAS is for proc_SQL. We can tune the program quite easily to generate, for example, data step. Here, proc_SQL is satisfactory, but you can adapt it to proc_SQL queries or data step if that's more appropriate or more efficient for your purposes. What you can do with this program is you can also change the analysis to a different table. Choose a library and choose a library that you know and switch the analysis to another table. In this example, we're going to switch to a table which has to exist called claim history. Every time you are changing the analysis, the table and the column metadata is regenerated, extracted, and injected into the large language model as a system message. When you type help, you get suggestions, personalized suggestions about the dataset. Therefore, you can start asking questions straight away. Questions that are being proposed, or maybe you want to research something that you are interested in, something which is not in the list of suggestions. The choice is yours. Depending on how complex your question is, a longer query may be generated at this point, and at the end you get back the answer in the same way. When you are done with the analysis, just write stop. That will end the conversation and terminate the SAS Compute session initiated in SAS Viya. In conclusion, this is how you can use natural language to interact with your SAS Viya environment using the Azure OpenAI assistant, which is generating SAS code and calling a function to execute in SAS Viya. Thank you for your time.